Joint origins and midplane joints. In this video, we'll create a revolute joint using between two faces, create a slider joint, edit joint limits, create a joint origin, and explain the differences and similarities between joint options. In Fusion 360, we want to get started with the supplied dataset, air cylinder and mount. When we take a look at this, you'll note that we have a couple different McMaster-Carr components. These are brought in from McMaster-Carr, and you'll notice that these are bodies inside of a top-level component. These are for an air cylinder as well as an air cylinder mount. Let's expand all of these and make note that the air cylinder mount contains multiple brackets. We have a left hand, a right hand side, as well as a pin with clips, but everything is free to move. So to get started, the first thing I like to do is go to Inspect and turn on Component Color Cycling, which will help me understand which components are together and which ones are isolated. Next, I'm going to go into my browser and go to Bracket L, right-click and ground it. This will keep this bracket in position, and then I can go to Assemble and create a rigid group between it and the right-hand side as well as the pin. Now my mount is going to be fixed in place inside of my 3D workspace. The next thing I need to do is figure out how to create those joints inside of the air cylinder. But remember, the air cylinder is comprised of multiple bodies. There's a nose nut, body 2, air cylinder body, the nut at the tail, and the shaft. Because we don't need all of these bodies, we're going to first select by holding down the Control or Command key, the nose nut, body 2, and nut tail. We're going to right-click and remove them. Remove places a feature in the timeline that allows us to roll back at any point in time or bring them back if we simply delete this feature. However, we only need to focus our attention on the air cylinder body and the shaft. As soon as we move either of these, they'll move together because currently they're just a single body. So the first thing I want to do is select both of them, right-click, and create components. Now we have our air cylinder and the shaft. Now I can make use of an as-built joint for the shaft and the air cylinder body. We're going to select as-built joint and set the type to slider. We'll select the air cylinder body and the shaft, and then we'll select a cylindrical reference on the outside and allow it to move back and forth and say OK. Next, we want to place the back of the air cylinder on the shaft of our bracket. When we do this, we're going to go to Assemble and select Joint. The motion type we're going to use is Revolute. And for the position, we have a couple different modes: Simple, Between Two Faces, and Two Edge Intersection. One thing that we can do, if this is going to be centered, is hover over the inside diameter of the back of our cylinder, hold down Control or Command, and navigate to the middle of that selection. Because we also have a shaft on the backside, we can do the same thing. This will automatically place it in the correct position for us. I'm going to select Cancel, and if for some reason we didn't have the pin and we only could move between the left and the right brackets, let's take a look at how we would accomplish this. Once again, we'll use Joint. Again, with Mode, we're going to start with Simple, hovering over the inside diameter and holding down Control or Command so we can select the mid. For the second one, we're going to select Between Two Faces. We're going to select the inside face, but notice that it doesn't allow us to select the face on the other side of the bracket. And this is because they're not the same body. This option Between Two Faces only works if they belong to the same body. In order to make this work, we have to create a joint origin. We can do this by going to Assemble and select Joint Origin. Using this Between Two Faces option will allow us to select multiple bodies or components, and then we can determine a snap location, which is going to be the center diameter of the bore. We're going to say OK, and now we've created a joint origin, which will allow us to go to Assemble, Joint. Once again, we can snap to the center position, and then we can snap to that center location. We also need to give it an axis of rotation. Notice in this case how the air cylinder doesn't actually fit between the brackets. They're a little too close together. But Fusion 360 is only taking into account our orientation, the location. Let's go to Motion and make sure it's set to Revolute, and we'll say OK. Now, if we zoom out, you notice that we can rotate the air cylinder, We can move the shaft inside and out, but it's under constrained. Let's revert our position and go to a back view. In the joints folder, notice that we only have Rev1 because that's between the two components. If we want to take a look at the slider joint that we created, we need to expand the joints folder that's inside of the air cylinder component. We're going to right-click and edit the joint limit. We're going to set this to a minimum and a maximum value. As we begin to drag these out, notice that it's moving the air cylinder. And in this case, that's going to be okay. We know that the travel of this air cylinder is going to be 5.5 inches. So we're going to set the minimum and the maximum values accordingly. When we take a look at this, because it's a negative value, our minimum is minus 5.5 inches and the maximum is 0. If we had an air cylinder that had, say, a spring return in it, we could set the rest position to a fully closed position or a fully opened position. We'll say OK, and as soon as we begin to move this, you'll notice that it automatically pops back out to that rest position. Now we're able to rotate the air cylinder as well as move the rod in and out. We can always go back and edit that joint limit and, for example, remove the rest option, which would allow the air cylinder to stay in whichever position it's in. We can always revert back to go back to its original position. So just a quick recap, we want to make sure that we understand the differences between an as-built joint and a joint. The functionality of the motion between these two are identical. However, applying an as-built joint makes use of the current position of your components, while a joint will allow you to select the location as well as the type of joint. We can create joint origins between multiple bodies to enable easier selection whenever we're creating those specific entities. In this case, an air cylinder between two brackets. And last, if we have multiple components that are stuck in the same position or bolted together, we can use a rigid group to make sure that they stay fixed. I'm going to bring the pin back temporarily, go back to a home position, and make sure I save this before moving on.